Hi everyone, so we're going to jump right into Unit 4. If you recall last week we finished up Unit 3, we were looking at covalent bonding. So we were looking at elements that had, when they got together, similar electronegativity values. And remember, electronegativity is their strength. So when they get together and they're trying to get their full octet so they can be happy like noble gases, they find that, they're engaged in this kind of tug of war with their electrons. But because they're similar strengths, neither one can really pull or win the electrons to their side, so they just decide to share them. In Unit 4, we're looking at elements where when they go to make a bond, one is significantly stronger than the other one. Therefore, one is able to rip those electrons away, and we form things that are called ions or charged particles. Okay, so we're going to do a little bit of review to start. Okay, remember that it's only our valence electrons, our electrons in our highest energy level, that are really participating in that bonding. Okay, so when we go to draw our orbital box diagrams today, we're going to see a couple of them. You're going to notice that I'm only using those valence electrons, okay, because the noble gas core doesn't actually participate in our bonding. Okay, and we want to remember our most stable elements. So what elements on the periodic table are all of our other elements trying to be like? They're trying to be like our noble gases. And why? Because our noble gases have 8 valence electrons already. So all of our other elements are going to try to gain or lose to be like them. Okay? The other thing we want to remember about our elements on the periodic table is that they have equal protons and electrons. All of our elements sit nicely at what we call electrically neutral, meaning positives and negatives cancel out, so we have an overall charge of 0. But what we're talking about in this unit is changing that 0 charge. Okay, so if we take an electron away, okay, so if we're starting with something like, let's say sodium. Sodium has 11 protons and 11 electrons. Okay, but now we're talking about changing that. We're going to take an electron away. So instead of 11 electrons, we're now going to have 10 electrons. Okay? If we have 10 electrons and 11 protons, the protons win and they win by 1. So we end up with a positively charged particle, and we call these cations. Okay? Now, let's go the other side of our periodic table, because we're going to see why in a second. And let's look at chlorine. Chlorine has 17 protons and 17 electrons. Well, what happens if we change this and we make this 18 electrons? Okay, so our chlorine has gained an electron. So now the electrons win. So we end up with an overall negative charge, and we call these anions. Okay, so this is what we're working with today. And by the end of this lesson, we should be able to look at our periodic table and say which elements are going to gain or lose, and how do we kind of predict their charges, and then how do we name those ions once we've created them. One last question I want to make sure we're all clear on is that we're only changing our number of electrons when making ions. Why is it that we cannot change our proton number? We've talked about this a couple times in class, and we've reviewed it after we've learned it, and that is if we change our proton number, we change our element. So hopefully that was not a new, bright, flashing piece of information for us. We're remembering that we never really want to touch that proton number. So we're only going to kind of fiddle around with our electrons in this unit. Okay? So we're going to look at our metals first. So if you recall, our metals are our elements that exist on the left, okay, the left, and the middle part of our periodic table when we're looking at it, okay? And we see that these have a tendency to lose electrons. So remember, it's all based on valence electron number. These elements tend to have 1, 2, 3 valence electrons, okay? And our elements are actually very, very lazy. They want to do the easiest thing possible for themselves. So if I'm sodium and I think to myself, well, I have 1 valence electron. If I want to be like a noble gas, I need to gain 7, or if I just lose 1, I can be like neon. Well, losing 1 or gaining 7, losing 1 sounds a lot easier, so it's going to lose that 1 valence electron. So we see that our metals tend to do this. Now, sodium exists in our alkali metal group. All of those elements have 1 valence electron, so they all tend to form +1 ions because they're losing 1 valence electron. Group 2 then, our alkaline earth metals are going to lose 2 valence electrons, so they're going to form 2+ ions. Now we're going to jump over to our boron group. That's technically group 13, but remember, we call this 3 valence electrons. Because it's 3, they're going to form 3+ ions, and we're going to pretend like our transition metals don't exist just for right now. We're going to pick them back up in about 5 minutes. Okay, so That is what we look at as predicting charges. Now, if I wanted to name these, it's very simple for our cations. It's going to be the name of the element plus the word ion. So if you look at the example at the bottom of the screen, we have magnesium 2 plus. Magnesium is an alkaline earth metal. It's in group 2. It has 2 valence electrons. So it's going to lose those 2 valence electrons to be like a noble gas. Okay? The element Mg is magnesium, and it has a charge. So all we're going to do is the name of the element plus the word ion. So this is called the magnesium ion. It is that basic. Okay, so we look at our periodic table now. We see here, these are our alkali metals. Okay, lithium, sodium, potassium, they all have 1 valence electron, so they're all going to tend to form 1 plus ions. Here's our group 2. Our group 2 is going to form 2 plus ions because they're going to lose their 2 valence electrons. We're skipping over our transition metals for right now. We jump over here to group 13 with 3 valence electrons. They're going to form 3 plus ions. Now this last group, the carbon group, is going to form 4 plus ions. Okay, the carbon group can also do something else if they really need to. So we see that this is the beginning of our pattern. Okay, 1 plus, 2 plus, 3 plus, 4 plus. Okay, these are elements that are all going to lose valence electrons. So we take aluminum as our example. Okay, aluminum has how many protons and how many electrons? So if we use our periodic tables, we're going to see that aluminum has 13 protons and 13 electrons. Now, if we look at its orbital box diagram for just its valence electrons, okay, it looks like this. Here's electron 11, electron 12, and electron 13. So we can see it's 2 choices. It can either lose these 3 to be like neon, or it can gain 5 more to be like argon. Which one is easier? So we're going to lose our 3, and we're going to make a 3 plus charge because we're losing all 3 of our valence electrons. And because it's a positive, it's just going to be the name of the element. So this would be the aluminum ion. Okay. Now we're going to do a little practice. So remember, it's the name of the element plus the word ion. So Rb is in group 1, so it has a 1 plus charge. All that really matters to us right now is it's positive, so we just call it the rubidium ion. Gallium we see as a 3 plus charge, so we call this the gallium ion. And then Ca2 plus, calcium, is going to be the calcium ion. And again, notice I'm not capitalizing anything while I'm doing my naming. Now, let's tackle those nifty little transition metals really quick. Those elements in the middle can do something pretty special. They can actually make multiple charges. Now, they technically do have 2 valence electrons, but remember they have d electrons, and sometimes they can use them as well. So because they can make multiple charges, we actually have to tell what charge they are with a Roman numeral. Now, a Roman numeral review just popped up on your screen for you. Okay, so these are the Roman numerals you need to know in order to name transition metals. Okay, so again, these are only that middle block, the D block, and an element's tin and lead. Okay, so what we're going to do is we're going to name the element, and then we're just going to tack a Roman numeral in there and then write the word ion. So our first example is the Cu plus. Okay, so Cu is copper, and it has a +1 charge right now. So when I go to name that, I'm going to call it the copper 1 ion. So I'm just using that Roman numeral 1 up here to indicate the number 1 charge. Okay, Mn is manganese and has a 4 plus charge. We're going to use our Roman numeral 4 right there. We're going to call this the manganese 4 ion. And then Co is cobalt with a 2 plus charge. So this becomes the cobalt 2 ion. Okay, so the only difference is we have to use those Roman numerals. Okay, we can't predict the charges based on where they are in the periodic table like we can for group 1, group 2, and then jumping over to 13 and 14. Okay, now last but not least, I want us to tackle our non-metal ions. Okay, so group 15, 16, 17, and we are going to talk about group 18 really quick. So group 15, okay, that's our nitrogen group. That set of elements has 5 valence electrons. So you see I put them here in the parentheses for us. And it's already popped up, they're going to form 3 plus ions. So if you think about their situation, with 5 valence electrons, they can either lose those 5 or gain 3 so that they have 8 total. Again, remember, they want to do what is humanly possible, the easiest thing in the world. So they're going to gain 3. So because they're gaining 3 electrons, they form 3 minus ions. Group 16 is oxygen's group. They have 6 valence electrons, so their choices are to lose 6 or gain 2. We're going to gain 2, so they're going to form 2 minus ions. Group 17 are our halogens. They have 7 valence electrons, so hopefully we're noticing the pattern. They're going to gain an additional electron, so they're going to form 1 minus ions, and then our noble gases do nothing. They're stable and neutral. They don't form ions. Okay, so we shouldn't see them at all in this unit. Okay, now when we name these, we name them a little bit different from our cations, but naming that you know, we're going to use the root of the name plus "ide" at the ending. So just like we did before, chlorine becomes chloride, phosphorus becomes phosphide. And so we're used to that from our previous unit. Okay, so these elements are, here are our halogens. Remember, they were 1 minus. Okay, here is our oxygen group, our 2 minus, and our nitrogen group was 3 minus. And remember, I said carbon could do something special, so they can actually be 4 minus. Okay, and I don't have the numbers up here, but if you recall, this was 1 plus, 2 plus, we skipped this section, 3 plus, and 4 plus. And now I'm telling you that this can be 4 minus, 3 minus, 2 minus, and 1 minus. So it does make a pattern as we travel left to right across the periodic table. Plus 1 plus 2, plus 3, plus or minus 4, minus 3, minus 2, minus 1, right? And then obviously 0. Okay, so let's do chlorine really quick. Chlorine has 17 protons and 17 electrons. If we just do its valence electrons, this is what it looks like. Here's 11 and 12, 13, 14, 15, 16, 17. So we can easily see that all it needs is one more valence electron to be happy. So it's going to gain that 1. It's going to end up with 18 electrons. So it's going to make a 1 minus charge. And then we're going to call this the chloride ion, okay, because it's our negatively charged ion. A couple practice ones for us. We see some negative charges on here. So we just want to practice with the root of the names. S2 minus, that's our sulfur atom. So sulfur would become sulfide ion. Our F minus, F is fluorine, so we become the fluoride ion, and As3 minus, that's arsenic, becomes the arsenide ion. Okay, so that's just a little bit of practice for us. And here's a table from the textbook that shows us some of our basic ones. Now, I want you to ignore all of the ones that have multiple elements in them right now. We won't get to them for a little bit. Looking at our fluoride, chloride, bromide, iodide, oxide, sulfide, nitride, and phosphide as just some common anions. Okay, we're going to skip over this really quick. We'll come back to our chart problem next time we do some notes. And I want you to look through the review. So remember, metals tend to form cations, so it's easier to lose 1 to 3 electrons than gain them. So we count the spaces it moves backwards to be like a noble gas, and that tells us it's charged, and we add a plus. Okay? So charge would equal the number of valence electrons. For our nonmetals, they tend to form anions. Why? It's easier for them to gain. Okay? So we go forwards towards a noble gas. The number of spaces equals their charge, and we add a minus sign. So for nonmetals, it's technically the number 8 minus its valence electrons to tell us its charge. So the last thing I want us to look at is, here are 4 example problems to help you in your worksheet this week. Okay, all I've done here is I found each of these individual elements on the periodic table. So for example, I found phosphorus. Okay, phosphorus is right here. I thought to myself, well, phosphorus has 5 valence electrons. Does it want to lose those 5, or does it want to gain 3 to be like argon? It would rather gain 3 electrons, which are negative. So we see that's going to be a 3 minus ion, and we're going to call it the phosphide ion. It gets the IDE ending because it's negatively charged. Calcium is right here in group 2. It has 2 valence electrons. So would it rather lose those 2 to be like argon, or gain 6 more to be like krypton? It's going to want to lose 2, so it becomes 2 positive because it's losing negative charges, and we just call it the calcium ion. Okay, bromine is right here. It's a halogen. It has 7 valence electrons, so its choices are to lose 7 or gain 1. It would obviously gain 1. So it becomes a 1 minus charge, and we call it the bromide ion. And then here we have rubidium. It's an alkali metal, just like sodium. It would rather lose its 1 valence electron than gain 7 more. Becomes 1 plus, oh, and that's a typo. That should be the rubidium ion. I apologize, everyone. And that's it for our notes today. So hopefully this makes a little bit of sense of just predicting our charges and naming our positive and negatively charged ions, and you'll get a little bit of practice. Hope to see you in office hours this week. Bye, everyone.